method from graphically depicting groups of numerical data through their quartiles based on a 5-number summary, that is minimum, first quartile, median, third quartile, and maximum value. And it also helps in finding the outliers. So the formula we use in R to make a box plot is first giving the variable for which we are creating the box plot, or it can be a two variable formula. Then the title, giving the labels of x and y axis, the symbol, color if you want to give to your box plot, and horizontal or vertical box plot if it is true or false. So let's start making a box plot. So here we are showing mean of MPG using box plot. So the formula for building a box plot is type of box plot function within the bracket. Give the name of x variable, that will be mtcars MPG. So I'm using MPG here and I'm using color green. So let's execute this command. So you can see I've created a box plot here. It is a basic box plot with highest value and the lowest value median. The area between the box is called the interquartile range. Now we are adding a AB line. So we will add a line to show the mean value of MPG. You can see it is the mean value of the dataset wherein it shows the mean of MPG. Similarly, you can also give lines for quantiles. What I am doing is I have given the formula AB line, which gives you a straight line with whichever formula you want to use. So I am here giving quantile of MPG column of mtcar dataset. So it is showing the highest value. Then there is the first quartile, then median, then third quartile, and the minimum value line. Next, we are building a box plot for MPG, where so you can see this in the graph that is built. It is a vertical box plot. Now we will be creating a horizontal box plot. For that, we are adding a subcommand that is horizontal is equal to true. T is for true. Let's execute it, and you can see the shape of the box plot is now horizontal. So here the values which were on y-axis, now they are on x-axis, and the direction of box plot has changed. Next, I am making a box plot with a formula wherein I am using the dataset insect spray. So let's see what this dataset is all about. It is the count of insects in agricultural experiment unit treated with different insecticides. So the data frame is of 72 observations and 2 variables, that is the numeric value, the count of insect, and the type of spray used on them. If you want to check the values, you can use head command for the first 6 values of the data set. So you can see there are count and spray variables, and there are values, the count of insects and the spray type used on them. So total there are 6 types of sprays that are used, A, B, C, D, E, F, G. The next I am using box plot formula to create a box plot wherein I have given the count with respect to spray and dataset name. Then the color is light gray that I have used here. So let's execute, and you can see a box plot has been created when the x-axis is spray and y-axis is the count number. And for each of the type of spray, a different box plot has been created. And you can also see the outliers here with a single point. In the C spray, it is the outlier. Outlier means it is a large value that will affect the mean, median, or maximum out of our range of the analysis of box plot. Next, we are using a sub command that is notch. So notch is used to compare the groups. In notched box plot, if 2 boxes notches do not overlap, this is a strong evidence that medians differ. So first let's execute this. In this case, I'm taking blue color for the box plots and I'm saying notch equal to true. So you can see what happened is the shape of the box plot has changed and there are notches wherein we can see if the notches do not overlap. So you can see they are overlapping, which means the median for each of the spray type is same. If they would not have been overlapping, the medians would have differed. So the notch, it explains the confidence intervals. That default is 95% confidence interval for the medians of each box plot, which means if the difference between the median and the second quartile and the distance between median and the third quartile are extremely different, as you can see in this last insect spray, or the sample size is very low, the notch will be wider. So you can see the notch is very wider here in the right one. If it is wider enough, that's the notch boundary is more extreme than the second or third quartile. That is, these are extremely different. The notch box will display like this inside out. So it is seen inside out. So it means they help us to understand the confidence level by which the mean is calculated, and if it is wider, or if the difference between the quartiles are wider, the shape will be inside out. Let's go for one more example using empty cars data set. Now I am saying MPG with reference to cylinders. So, and data set is empty cars. I am giving the name of my x-axis as number of cylinders and y-axis as miles per gallon. Notch is true. So the shape should be like inside out, and they should overlap. The data should overlap in order that it means are same for the data. And the title will be mileage data. Colors, I'm taking 3. In this case, the MPG is based upon cylinders, and my cylinders are 3 in count. So I have taken 3 colors, green, yellow, and purple, and I have named them as high, medium, and low. Let's execute this command, and you can see 3 blocks plot has been created, and they are notched, and there is one outlier in the low box plot data. So if I would have done it false, so you can see it is a normal box plot. The data is not notched here. So box plot is easy to understand. By using it, we can get the values of maximum, minimum, median, and quartile values, and the outliers in our data.